Okay, so we're doing chapter 12, which is corresponding to quiz 2 of my book, Overcoming Digital SAT Math. So remember, if you have a copy of this, attempt to do it on your own first, do corrections by yourself first, before watching this video for explanations on anything you cannot correct on your own to get the best results. So let's start by going over number 1. So which of the following equations has no real solutions? So no real solutions, if we're talking about, what do you call them, quadratic, something with a highest degree of 2 as the leading exponent right there. When they're talking about the number of real solutions, you're usually going to be using this guy right here, which is called the discriminant formula. And when the discriminant formula equals a negative value or a value that is less than 0, that's when you have no real solutions. So once you have a quadratic set equal to 0, which it's already nicely done for you right here, you're going to determine what A, B, and C are. And then once you plug those in, if it's less than 0, it's no real solutions. So let's determine for A, for answer choice A, what A, B, and C are. So A is going to be the value 7 that's being multiplied by x squared. B is going to be 7 right there, the value times x. And then C is the number that's being added or subtracted on onto that, which in this case there's technically like a plus 0. We just aren't going to write that typically, so we're just going to assume that C is equal to 0 here. So now we can plug that into the discriminant formula. So that's going to be 7 squared minus 4 times 7 times 0. So we know that this, when we multiply, is going to be 0. 7 squared is going to be 49. That's obviously not a negative value, so we can cross that out. Over here, our A is going to be 7, and then our B is going to be 0 because there's nothing being multiplied by x, so 0. And then our C is going to be negative 7. So now let's plug that into the discriminant formula. So we have 0 squared minus 4 times 7 times negative 7. And we want this to be less than 0 if that's the answer. Now, you don't even need to get the actual value. You just need to know, is it negative? Is it less than 0? So if we have 0, and then we're going to subtract all of this once we multiply it, well, if I'm subtracting what 4 times 7 times negative 7 is, I'm going to be subtracting a negative value, which is the same thing as adding. So 0 plus something is not going to give me a negative value, so it can't be answer choice B. So now let's go to C. So for C, we're going to have A is equaling 7, B is negative 14, and C is equal to 7. So let's plug that into the discriminant formula. Negative 14 squared minus 4 times 7 times 7. So negative 14 squared, I think that's 196. Don't quote me on that. I'm terrible at remembering my perfect squares and stuff. So I'm going to check it. Yeah, 196. 196. And then we have 7 times 7 is 49 times 4. That's going to be, carry the 3, 196. So minus 196, that actually equals 0. So it's definitely not that one. So we know it's going to be D. But let me just prove to you why using the discriminant formula. So A is going to be 7 here, B is going to be 7 here, and C is going to be 7. So we plug that into the discriminant formula. And if we get something that's negative, it means there's no real solution. So this is going to be 7 squared minus 4 times A is 7 times C, which is 7. So this is going to be 49 minus 196, which obviously is going to give you a negative value. So that's how you can prove it for number 1. Now for number 2, we're going to find out what the value of C is. So here they tell us that A over B is equal to 6. So I have to think, okay, with the second equation, how can I manipulate it to get just an A over B so I can use this information to my advantage? So I'm going to say, okay, this second equation, I can rewrite it as, oops, why did it do that? I can rewrite it as 3 over C times A over B. That's kind of just like what the precursor to that is. Like if I multiply this together, I get that. So it's the same thing. And that has to equal 240. Now I have a over b by itself, so I could say, oh, I know that that's equal to 6. I can replace that with a 6. So now I have 3 over c times 6 is equal to 240. So now I can just say, okay, that's the same thing as 6 over 1. 3 times 6 is 18. C times 1 is c, and that equals 240. I can multiply each side by c, so then I just have 18 is equal to 240c. Divide each side by 240 to get c by itself. So then I just have c is equal to 18 over 240. And then obviously I need to simplify that if I'm going to keep it as a fraction, but it would probably be easiest to just do it in your calculator as a decimal on the digital SAT, since you have access to a calculator the whole time. So that's what I'm going to do. So then this would be 0.075 as a decimal. So let's now go to number 3. What type of function, and thank you guys for the likes, what type of function is graphed below? So I love these because in math, so much of like definitions with names just kind of give away what they are. Like linear literally has the word line in it, because it should be like a straight line, which we don't have here. So right away I see linear and there's not like a straight line right here, so I can cross out C and D. So it either has to be increasing or decreasing exponential. The way I determine if it's increasing or decreasing is by saying, okay, just like how we read and write, we go from left to right and we say, is it going down or going up from left to right? Well, if I go from left to right, it's decreasing, it's going down. So it's a decreasing exponential function, B. Thank you for the shares and likes, guys. So let's go to number 4. So for number 4, it's asking what value of n is, basically, does this equal this? So you can start foiling this all out if you want, or you can see, okay, it's something squared, right? So what squared, like, how could some value minus 6 squared equal some value plus 6 squared? Like, how could these be equal? Well, you could put a 0 in for n. Like, you can kind of just guess and check with easy values first. That's what I would do to save time. And I would say, okay, I'm going to try 0 in there, because I know that if I have the negative of a value squared, it's the same thing as having the positive version squared. And the way to get that same negative and that same positive value is to plug in a 0 right there. So then I could say that's negative 6 squared is just 36 equals 36, yes. So I could say n equaling 0 works. That's the most efficient way. Again, you could FOIL out as well, and then you'll be able to get to that conclusion as well, but not as efficient. So let's go to number 5. We have the system of equations right here, and we want to find the solution. So systems of equations, you can solve multiple ways. You could do substitution, elimination. You can even like graph it. You have access to Desmos on the digital SAT, or like whatever calculator you want, as long as it's approved. Typically what I like to say is if they've already isolated y for you, that's typically substitution is the easiest method. Like if they've already substituted isolated y or x, so it's just like x equals something or y equals something, substitution is usually the easiest. Or just pick one method and stick to it if you want to do that. So I'm going to just use substitution here. So I'm going to say I have negative 2x minus 2 times what y is. Well, I know y is equal to 4x minus 20. So instead of y right here, I'm going to substitute in 4x minus 20. And then that's going to equal 10. Now I just have to distribute right here. So I'm going to copy down negative 2x. And then I'm going to say negative 2 times 4x is negative 8x. Negative 2 times negative 20 is going to be plus 40. And then that's going to equal 10. So now let's combine our like terms right here. So negative 2x minus 8x is negative 10x. Plus 40 is equal to 10. And then I have to subtract 40 on each side, so then I get negative 10x is equal to negative 30. Did someone ask a question? I'll look at the comments after I finish this. So negative 10x is equal to negative 30. So then we're going to divide by negative 10 on each side to get x by itself. And then that's going to give us that x is equal to 3. So just from that, we can cross out c and d, because we know x has to be 3. But we need to know what y is. So all you have to do now is plug in this for x and find y. And you could use either equation to do that, but it's probably easiest to just use the one where y is already isolated. So I'm going to just do that and plug in 3 for my x value right here. So it's going to be 4 times 3, which is going to be 12. Y is equal to 4 times 3, which is 12, minus 20, which equals negative 8. So negative 8 would be my y value, so it's 3 comma negative 8. Did someone ask a question? Let me see. I don't see anything. I don't know. Someone asked, are these sterling silver? I don't know what that means. Okay, so let's go to number 6. Number 6, if y is equal to kx, where k is a constant, and y is equal to 30 and x is equal to 5, what is the value of y when x is equal to 4? So this is one of those directly proportional relationships, just shown in a different way with the formula for directly proportional relationships. Y is equal to kx. What you have to do for these is you have to first figure out what k is, then plug that in for k right here, and then you have an equation that you can use to answer the question. So I'm going to start by plugging in 30 for y, and then I have k times what x is, which is 5. That's going to allow me to solve for k. So I'm going to divide by 5 on each side to get k by itself, so then I get 6 is equal to k. So now I can plug that in for k and have an equation that says y is equal to 6 times x. Now I can use this equation to find out what y is when x is equal to 4. So I'm going to put 4 in for x to find y. So 6 times 4, so that's going to equal 24, B. Okay, so now let's go to number 7. The equation above can be used to model the amount of battery life B in minutes left on a cell phone when running C applications simultaneously. Based on the model, which of the following is the best interpretation of the number 7 in this equation? Okay, did someone ask? Someone asked about doing number 6 again. So this will be posted on YouTube later, so you'll be able to see me do number 6 again if you missed it. Okay, so let's go and do this one. So we're finding out what the number 7 means in this context. Okay, so B is the amount of battery life in minutes left on the phone after running C applications simultaneously. So this is in the format of a linear equation, like how y equals mx plus b, how we're used to that. It's just that they're using different letters. So like in this context, y is like your b, and c is like your x right here. So the number that's being multiplied by c is your slope. So negative 7 is your slope. What do we know about slope? Well, we know that slope is the change in y over the change in x, or in this case, if b is acting as y, it would be the change in b over, if c is acting as x, the change in c. So let's look at our units. Well, what are the units for b? So b is the amount of battery life B left in minutes on the phone. So battery, I'll put like BL for battery life in minutes is the units for that. And then for C, it's going to be like the number of applications running simultaneously. So number apps running simultaneously, I'm going to just put sim for simultaneously. Okay, so knowing that will help us a lot with interpreting what that number 7 means. So let's go through it. A says every additional application open will cause the battery to drain 7 minutes faster. So if our slope is negative 7, which is the same thing as negative 7 over 1, does that match? Let's see. So C would be the number of applications, like the additional application part. So it's saying for every additional application, for every one application that matches, open, will cause the battery to drain 7 minutes faster. So the battery will go down by 7 minutes. So that matches with the units and the interpreting the units in this context with the number 7. So it would be A. That's probably the easiest way to do these types of problems. You have to think in units to match it to the interpretation that's correct in the answer choices. What kind of iPad pen do you use? This isn't an iPad, this is a Samsung. It's like the pen that came with it. I think it's like the Samsung 7 or something. IDKY, you can't see your comments. I'm only seeing some comments, I guess, if you put something. Yes, yesterday I was asking her something, but didn't seem like she saw my comment. Oh, I'm sorry, guys. If I'm not answering your comment, like, I try to pay attention to it. I might have missed it, but sometimes it tells me that comments are filtered, so I don't know, maybe it's like filtering comments by accident. But if you have a question that I don't answer, like I don't see it on the live, you can always use the Q&A tool on my profile too. So let's go to number 8 now. Triangle ABC is a right triangle. AB is the hypotenuse of the right triangle. Okay, so let's start drawing this. So we have a right triangle like this, and AB is going to be the hypotenuse, so the side that's across from the right angle, AB. And then that means that this has to be C. So AC is equal to 5, so let's label this with a 5. BC is going to be 12, so let's label that with a 12. A student draws a point on the hypotenuse of this triangle and labels this point D, so let's draw that. The measure of angle ACD, so like, let's draw a little like dotted line right there. ACD is this guy right here, is equal to X. So this is X equal to X degrees. The measure of DCB, so this guy right over here, that angle, is going to be equal to Y degrees. What is the value of sine of X minus cosine of Y? So, X and Y are both complementary angles because they both add up to a 90-degree angle. Like you have this portion right here plus this portion right here would be X plus Y, which add up to 90 degrees. So we know that they're complementary angles. They add up to 90 degrees. That's important because there's some trig identities with sine and cosine that have to do with complementary angles that might help us out here. So if I'm doing, if these are complementary angles, I know from my trig identities that like the sine of one equals the cosine of the other and vice versa. So that means that the sine of X has to equal the cosine of Y. The sine of one complementary angle equals the cosine of the other. So if I start to try to figure out what sine of X minus cosine of Y is, I could say, oh, sine of X minus, if I want to plug in something else for cosine of Y, I could say, oh, sine of X is the same thing as cosine of Y. So I could just subtract sine of X, and that's going to cancel out to give me 0 as my answer. I'm taking Algebra 1 right now. Is the SAT everything you've ever learned? No, there's some stuff. Also, schools go in different orders sometimes with like what they include in their like math classes and how they go. So there's Algebra 2 stuff on there. And there's also going to be like, I don't know if your school like includes trig and like pre-calc stuff, or like sometimes they do like portions of it. It's weird. It's at every school's different. But like there's other stuff like pre-calc and trig, which typically students take after. So then let's go to number 9. So we have this, which is like an absolute value type of situation right here. Remember, absolute value just means that like you take whatever's inside the parentheses and make it positive, basically. So we're going to start by dividing by 2 on each side to isolate the absolute value bars. So it's going to cancel on the left. And then if I do 10x divided by 2, I get 5x. Negative 8 divided by 2 is going to be negative 4. Now, you have answer choices here that it would probably be the best option for you. Well, it definitely is the best option on the ACT or SAT to just plug these in to see what's correct, because if you solve, once you solve absolute value problems, you're going to have to plug in what you get for X anyway to make sure it's right, because sometimes a value you get ends up being impossible in the given context. So you have to plug in anyways. But I'm going to show you how to do this if like you have to do this for like a free response problem at school. So we're going to first say, okay, 3x minus 7 can equal the positive version of 5x minus 4, or we can get that it equals the negative version of 5x minus 4. Because think about it, if you have the absolute value of something like 6, that equals positive 6, it could also be the absolute value of negative 6 equals positive 6. You could have the negative version or the positive version. So we're going to say, okay, it's equal to the positive or the negative version. And then we're going to say, okay, we're solving for x. So I'm going to subtract 3x on each side. So then I'm going to get negative 7 is equal to 2x minus 4. And then I'm going to say I'm going to add 4 to each side. So then I get negative 3 is equal to 2x. So then if I divide by 2, I get x is equal to negative 3 halves, which is the same thing as negative 1 and 1 half. Now you'll see that that's in the answer choices, but remember you have to plug it in to see if it actually works. And I'm going to show you why right now. So I'm going to plug in negative 1.5, which it's probably easiest for people to just plug it in as negative 1.5, like a decimal. I'm going to do negative 1.5 times 10. That's going to give me negative 15 minus 8. So negative 15 minus 8 is negative 23. So this is saying that I should get negative 23 when I do 2 times all of this when I plug in negative, that's supposed to be a negative 1.5. Let me write it a little bigger. Negative 1.5 for x there. I don't even have to start like doing the actual math here to know that that's wrong, because I'm getting a negative on this side when I'm having 2 times something that should be a positive value. There's no way that I get a negative answer on this side if I have 2 times something that should turn into a positive no matter what's inside, because I have absolute value bars. So there's no way to get a negative answer, so that's impossible. So it can't be the one with the any of the ones with negative 1/2 in it. So now let's solve this one. So we're going to have 3x minus 7 is equal to negative 5. Oops, kind of looks like it's part of the equal sign. So negative times 5x, negative 5x, negative times negative 4 is positive 4. Now we're going to add 5x to each side. So then I'm going to get 8x minus 7 is equal to 4. And then we're going to add 7 to each side. So then it's going to be 8x is equal to 11. And then we're going to divide by 8 on each side, and we're going to get that it's equal to 11/8. Now, I kind of do this in my head, and I just realized I didn't explain what I was doing for this one to turn it into a mixed number. But if you want to see like the whole process to turn it into a mixed number, it's just that 11 goes inside the long division house, 8 goes on the outside. And so you just say 8 goes into 11 one time, and then you multiply. 1 times 8 is 8, subtract, that's 3. There's nothing left to bring down. So once you get to this this portion where you have that remainder of 3, the remainder becomes the numerator portion of your mixed number, and then the number you divided by on the outside becomes your denominator. So it's 1 3/8. So 1 3/8 definitely has to be the answer, because like it's out of the options that are left, like we have nothing else to go off of. Like x could have only been that, negative 1.5 or 1 3/8. And we already disproved that this one doesn't work, so it can only be answer choice C. But if you plug it in, you'll see that it works as well. So that's why it's important to plug in for absolute value problems. Okay, so let's erase that and go to number 10. On essay, hold on, sorry, I think I missed some questions. What does the GED test have on it? Like, what should I study? I don't do that one as often, so off the top of my head, I don't know, but I know it's very similar, like, to a lot of the stuff on the SAT. I'm in 8th grade, so that's why IDKIS. Does the SAT vary for schools? I was saying that math classes vary for different schools, like the order that they do it in and like what they call their math classes and everything. But the SAT is a standardized exam, so no. On the SAT, are you allowed graphing calculators? Yes, it just has to be an approved calculator, or they actually, now since the SAT is all digital, it's like built into the test when you take it, that they have Desmos on there. So way to jump scare me. Okay, sorry. Okay, thank you for the likes and shares, guys. Let's keep going to number 10 now. So for number 10, we're trying to find the minimum value. So a lot of people get confused with like minimum value of like whether they're supposed to be finding X or Y. So when it's asking you for minimum or maximum value, it's asking you for like the Y, or in this case, the f of X, same sort of thing. Like the Y value that the minimum's at. If it's asking you, so if it phrases it like find the X value, the X value or X coordinate, something like that, when you have the minimum value, something along those lines, that's when it's asking for the X. So here we're being asked for Y when we have the minimum, or like you could also think vertex, like the Y of the vertex is another way to think about that. So we're going to FOIL this out first. So FOIL is an acronym that stands for what we're going to multiply together. So F stands for multiplying the first things together, 3x times 3x, so that's going to be 9x squared. O stands for multiplying the outer things, so negative 6 times 3x is negative 18x. I stands for multiply the inner thing, so 4 times 3x, so that's going to be 12x. L stands for multiply the last thing, so 4 times negative 6 is negative 24. And that all equals f of x. So we're going to now combine like terms right here. So then we're going to have 9x squared minus 6x minus 24 is equal to f of x. And then, so to find the x min, or in other cases it might be called like the x max, what we do is we use the formula negative b over 2a. And then to find the y min, or y max in another problem, all you have to do is plug that in to the equation. So you find the x min and then plug it in for x to find the y min. So let's start by finding the x min. So a, b, and c are the same thing that are that is a, b, and c that you're used to in the quadratic formula. So a is just the number being multiplied by x squared, b is the number being multiplied by x, and c is the number floating on by itself. So to find x min, it's going to be negative b, which b is negative 6, so the negative of negative 6, over 2 times a, which is 9. Negative of a negative is a positive, so that's going to be 6 over 2 times 9 is 18. Then if we divide by the greatest common factor on top and bottom, it's going to be 1/3. So that's the x min. But remember, we're being asked for minimum value, so we have to find the y min by plugging this in for x. So now I'm going to plug in 1/3 for x. So it's going to be 9 times 1/3 squared minus 6 times 1/3 minus 24 is going to give me f of 1/3. So it's going to be 9 times 1/3 times 1/3 is 1/9. And then 6 times 1/3 is going to be 2, so minus 2. And then minus 24. 1/9 of 9 is just 1, so 1 minus 2 minus 24. So that's going to be 1 minus 2 is negative 1. Negative 1 minus 24 is going to be negative 25. So the correct answer would be D. Okay, so let's go to number 11. Let me just erase this. Okay, so which of the following is the correct equation for a circle with a center at -3, 2 and a radius of 4? So for this, you have to remember the equation of a circle formula, which says that it's x minus h squared plus y minus k squared equals the radius squared, where h comma k is the center of the circle. So let's look and see, okay, if our center of the circle is -3, 2, that means that, I like to remember it as, instead of like looking at H and K sort of here, I like to remember that I should be looking for the opposite of what the X is for the center next to my X value. So like I'm looking for the opposite of -3, which is +3, to be next to an X. So I'm going to cross out these because that doesn't match as having a +3, like +3 next to my X. And then the same thing for the K value, or the value that's supposed to be next to the Y, which represents the Y for my center of the circle coordinates. So I need to think, what's the opposite of 2? The opposite of 2 is -2, -2. So I need to look for something with -2. Well, they both have that. So now I'm just going to determine, okay, which of these is correct, the 16 or the 4. Remember, it all has to be equal to the radius squared. So if the radius of the circle is 4, it has to be equal to 4 squared, the radius squared. So obviously it's going to be 16 because 4 squared is 16. So it's A. Thanks for the content. Do you have any advice for the Algebra 1 regions? Just practice over and over again and do corrections. That's pretty much going to be my advice for any sort of like math testing situation or any standardized prep. Especially with math, it's just doing the problems that you're used to, like the same kind of format that's going to show up on the exam over and over again, and doing corrections over and over again. Don't just like read the explanation or the answer key and be like, oh, I got it. Like actually try to correct it yourself on your own is going to be the most helpful thing. So now let's erase this. And let's figure out number 12. Which of the following is equivalent to the expression right here? So this is one of our laws of exponents, power rules, whatever your teacher calls them, that says if we want to rewrite this with a fraction as the exponent, it's going to be that the numerator is the number that it's being raised to on the inside, that exponent on the inside, which is 8. And the denominator is the type of radical it is. So the type of radical it is it's a 5th root, so it's going to be a 5 on the bottom. So the correct answer would be C. Let me just get water really quick, guys. Okay. So, it's going to bother me. Okay. So now we're going to do number 13. So an alternative rock band sold a lot of tickets to their various concerts over the years. The graph above shows the amount of tickets sold each year for a certain period of time. The tickets sold for 1976 is what fraction of the tickets sold in 1981? Okay, so this is the tickets in thousands. So 1976, right? Yeah, 1976 is over here. So that's going to be 20,000. Tickets are sold in 1976, and then the tickets sold in 1981 is going to be 25,000. So if we want to set that up as a fraction, it would be 20,000 over 25,000. You can cancel out a 0 on top for every 0 on bottom, then you just have 20 over 25. And if you divide by the greatest common factor of 5 on top and bottom, you get 4/5 as your answer. So this graph is going to be for questions 14 through 16. So let's start with number 14. For the line graph above, what is the y-intercept? So you could easily see that like y-intercept where it intercepts, where it touches the y-axis, which is right here. So each of these squares represents 1. You want to be careful and like check for that scale because sometimes it's not that easy. Sometimes they have it going up by 2 or something like that. But this happens to just be going up 1 unit each time. So we can say that the y-intercept is 3. Meaning, remember, y-intercept is the y value. So the y value is 3 when the x is equal to 0. So 0, 3 is the correct answer. So for the next one, it's asking what is the x-intercept? So the x-intercept is where it intercepts the x-axis. Now, you don't want to just go off of your eyeballs for this all the time, because sometimes they try to trick you. So what you want to do instead is come up with a linear equation for this. Well, I don't like that that's not filled in. You want to come up with a linear equation for this using y equals mx plus b, then plug in 0 for your y to find the x-intercept. So y equals mx plus b. M is your slope, b is your y-intercept. So we already know y-intercept, b is 3. So now let's figure out our slope. Well, let's pick 2 perfect corner points to figure out our slope. So I'm going to pick a perfect corner point right here, meaning like perfect corner, like it's right on the corner of a square. And then I'll pick this one right here. And then going from left to right, I'm going to see how do I travel to figure out the slope, because slope, or m, is equal to how much you're going up or down over how much you go to the right. And if you're going up, it's a positive slope. If you're going down, it's a negative slope. So I'm going down by 2, so it's going to be a negative slope, down by 2, and then to the right by 1. So it's going to be negative 2 for my slope. So now if I plug those in, I have a linear equation that I can now use to solve for my x-intercept. So to solve for x-intercept, I plug in 0 for y, right there. And I'm going to say 0 is equal to negative 2x plus 3, minus 3 on each side. And then I'm going to now divide by negative 2 on each side. So then I'm going to have positive 3 halves is equal to x, which that's the same thing as 1.5 or 1.5. Just remember that on the digital SAT exam, you can't write 1.5. Like, it'll read that as 11 over 2. You can't do mixed numbers on the digital SAT exam. You would have to do it like 3 over 2 or do it as 1.5. So just be careful with that. Now for number 16, thanks for the shares, guys. So for number 16, if line M is perpendicular to negative, why are you guys saying negative 2? Yeah, that's negative 2 right there. Maybe I said positive by accident, sorry, but I wrote it. So then number 16 also applies to that same graph. If line M is perpendicular to the line graphed above and passes through the point negative 3 comma negative 1, then what is the equation of line M? So remember, perpendicular, that's the one where it's the negative reciprocal slope. So I'm going to rewrite, we know the linear equation for this line, so I'm going to rewrite it. The linear equation for the line that we were just working with is y is equal to negative 2x plus 3. So that's the graphed one, right? We want the equation of the perpendicular line. So perpendicular means that we're going to have a negative reciprocal slope to this one. So the original slope is negative 2 over 1. We want the negative reciprocal, or like you could think of it as changing signs and then taking the reciprocal. So this is now going to be positive, and I'm going to flip it upside down to be 1/2. This is my new slope. This is my M for the line that I'm interested in, my slope for this line. And then they gave me a point, x comma y, so they gave me an x and a y that I could plug in to help me complete my equation. So if I'm doing this in y equals mx plus b format, because it's a line, I'm going to say, okay, I know y could be negative 1. I know that my m, my slope, is 1/2. I know that my x, if y is negative 1, is going to be negative 3. And then I just have plus b. So now I can use this to solve for b. Then I can just easily plug in m and b to figure out which of these is the correct equation. So let's do that. So we're going to have negative 1 is equal to negative 3 halves. When I multiply that, I get negative 3 halves plus b. Then I'm going to add 3 halves to each side. So now I have negative 1 plus 3 halves is equal to b. Now remember, if we're working with fractions and we're adding or subtracting, we need to have the same denominator. So I'm going to multiply by 2 here on top and bottom to get that same denominator of 2. So that's going to be negative 2 over 2 plus 3 halves equals b. And then that's just going to be 1 over 2 equaling b. So b is equal to 1/2. M, we already figured out, was also equal to 1/2. So we would just plug in 1/2 for m, 1/2 for b, and it should just be 1/2 x plus 1/2. Let's see which one says that. 1/2 x plus 1/2. So it would be answer choice A. Thank you guys for the likes and shares. So let's keep going now to number 7. Which of the following points is a solution to the system of inequalities given above? So if it's a solution, remember all points are x comma y. If it's truly a solution to the system, that means that when you plug in, like for instance, if we're checking answer choice A, if answer choice A is truly the solution to the system, that means that when we plug in 0 for x in both of these, that's important, in both of these, and we plug in -11 for y in both of these, that we get a true statement, basically. So let's try testing out A now. So A says that our y should be -11, so I'm going to do it in the top one now. So -11 is greater than or equal to -3. If we're testing out A, then our x would be 0, and then -2. So it's saying that -11, the whole question just is asking us to find out which of these is the solution. So this is saying -11 has to be greater than, -3 times 0 is just 0, 0 minus 2 has to be greater than -2. That's not correct, so it can't be answer choice A. So now let's test out answer choice B. Let's say, okay, now I'm going to put 0 for my y right there. And then I'm going to say, hold on, let me put this down now that I've shown the question because it's hard to write at the same time. So now I'm going to put in 0 for my y to test out B. And I'm going to put in -11 for my x. So 0 needs to be greater than or equal to -3 times -11 is going to be +33, minus 2. That's going to end up being 31. 0 is not greater than or equal to 31, so it's not going to be B. So let's erase that. Now let's test out answer choice C. C says that we're going to plug in 11 for x and 0 for y. So let's do that. 0 for y, 11 for x. So when we do that, we're going to get 0 is greater than or equal to -3 times 11 is -33, and then minus 2 is going to be -35, and that is true. 0 is in fact greater than or equal to -35, but it has to work for the second one as well. So let's try that now. So we're going to plug in into the second inequality in the system, 0 for y, and we're going to say 0 is less than or equal to, and then for x, I'm going to plug in 11. 11 plus 5. So 0 is less than or equal to 16. That also works out, so it has to be C. So if the point, when you plug it in, works for both of them, it's definitely the solution. Now, for this one, we want to see what data matches the frequency table shown below. So frequency is telling you like how many times that number shows up in the data set. So like when it says 4 corresponds to the number 2, like 4 frequency for the number 2, it means that the number 2 shows up 4 times in your list. So it means you have this, basically, like 2 written 4 different times. Like the frequency tells you how many times you write that number. Or sometimes we'll call it a value instead of a number, but same thing. So I'm looking for something that has 4 different 4 different 2s, and then 2 different 4s, and then 3 different 5s, and then 2 different 6s. So let's see which one says that. So then that would just be B right there. Okay, I think that's it for quiz number 1. Let me go and do quiz number 2 now. I forget what page that's on. Hold on. Let me check on my thing. It's not showing me. Okay. 129. No, I didn't say that. There we go. Okay, so now we're going to do quiz number 3. So, again, if you're watching this and you have access to this on your own, attempt the problems and corrections first before watching this video for explanations on stuff that you can't figure out on your own. So let's start with number 1. Which of the following expressions is equivalent to this? So we're just going to FOIL here. FOIL is an acronym that stands for what you multiply. So F stands for you multiply the first thing. So B times A squared is just going to be A squared B. O stands for you multiply the outer thing. So B times B is just B squared. And then I stands for you multiply the inner term. So A squared times C. So A squared C. L stands for multiplying the last thing, so C times B, BC. And then we're going to see, okay, what matches with that. So let's see. I think that's B. Yeah. Remember, it doesn't matter the order with, I forget what the property is called, but I think it's like associative. I always get them confused. Associative property, I'm pretty sure of addition where it doesn't matter the order that you add in. So it's B, just in a different order. So then let's go to number 2. The linear function h is defined by this. What is h of 5? So 5 is in these parentheses right here, right? X is in these parentheses right here. So it's basically saying replace x everywhere with 5 and see what you get. So I'm going to replace, oops, I don't like how I underlined that. I'm going to replace all the x's with 5. So I'm going to say h of 5 is equal to 3 times 5 minus 4. So h of 5 is equal to 3 times 5 minus 4 is 1. So that equals 3. So the answer should be D. Okay, now let's go and do number 3. So this is asking for sum of solutions. Sum of solutions is a formula. I mean, technically you could find each of the solutions and add it up because it is like it's the sum of the solutions, like adding up all the solutions, but that's way like too much work when you can just memorize a formula. So the formula for sum of solutions is just negative b over a. So all you have to do is set the quadratic equal to 0. I mean, in this case, it doesn't really matter as much. It's not going to mess you up, but I tell all my students, get in the habit of always setting the quadratic equal to 0 for the formulas because sometimes it will mess you up if you don't do that. So I'm going to set this all equal to 0 by subtracting 5 on each side to move it. So just like with quadratic formula, what you say is A, B, and C is the same. So A is going to be the number that's being multiplied by x squared. So A is 4. And B is the number being multiplied by x. So if I want to do negative b, negative of negative 3, over, and then for a, I'm going to have 4. So it's going to be 3/4 as my answer. Okay, let me erase really quick. Or just factor, right? You could do like the factoring, the quadratic, all of that if you want. And like find the solutions and then add it up, because it's not just asking solutions, it's asking the sum of the solutions. It's just a lot more work. So like you can find out what the solutions are, but then you just have to add them up. A particular circle has a center at -3, 2. The point -3, 11 lies on the circle. Which of the following is the correct equation for the circle? Okay, so remember, equation of a circle, x minus h squared plus y minus k squared equals r squared, the radius squared, and h comma k is the center of the circle. So basically they gave us the center, so we know what should be going next to the x and what should be going next to the y. I like to remember it as like the opposite of this value right here for the center. Like the opposite of -3 is +3, so I have to have a +3 next to x. So I'm going to cross off these guys. And then I have to remember, I remember it also as like the opposite of this value here, for the center. So the opposite of 2 is -2. So that's what I need to have next to my y, which both of those have, equals the radius squared. So we have to figure out what the radius is to figure out which of these is correct. So it says that the point -3, 11 lies on the circle. So if you have a point at the center, like you have the center point, the center of the circle, and then you have, let me draw it out. So we have -3, 2 right there, right? And then we're going to say, okay, now we have -3, 11. So like, let's say that's up there. -3, whoops. -3, 11. Going from the center of the circle to that point would give you your radius. Like that's the radius represented by that line. And you don't even have to do distance formula or anything because it's just going straight up because they both have the same x value. So you just have to figure out the distance between the y values, like the 2 and the 11. So the distance between those would just be 9. So the radius is equal to 9, and you want it to equal the radius squared, so it has to equal 81. So it would have to be A. Oops. Okay. So now let's go to number 5. Which expression is equivalent to this one right here? So we're going to, this you have to remember because they like to try and trick you sometimes with this, because students try to like distribute, or not distribute, but like do the power to a power rule for each term inside. You can't do that because there's a plus there. You have to remember that when something is squared, it just means that you're timesing it by itself. So what this is saying is that we have this. Like you just times it by itself. So if we have two terms plus or minus in parentheses times 2 terms plus or minus in parentheses, we have to FOIL it out. So we have to multiply, F stands for we multiply the first thing, so m over 2 times m over 2 is going to be m squared over 4. O stands for I multiply the outer thing, so m over 2 times n over 3, which is going to be m n over 6. I stands for multiply the inner, so n over 3 times m over 2, so that's going to also be mn over 6. L stands for multiply the last term, so n over 3 times n over 3. So it's going to be n squared over 9. So now let's combine our like terms right over here. So then we're going to just copy down m squared over 4, combine our like terms right over there to get 2mn over 6, and then just copy over the n squared over 9. And then let's reduce this by dividing by the greatest, or simplify it by dividing by the greatest common factor on top and bottom, which happens to be 2. So then that just cancels out to 1 times mn, so just mn. And then 2 goes into 6 3 times. So then this becomes mn over 3. So let's see which says that. That would just be answer choice D right there. So let's now go to number 6. So this is looking like, yeah, probability. So if the table below represents the distribution of students in a certain high school who take either French or Spanish for their foreign language class. If a student is selected at random, what is the probability that the student is a boy who takes Spanish as a foreign language? So remember, probability is the desirable outcome, or like what the question's asking you to be the outcome, over the total number of chances, or like the total possible outcomes. So the question's asking you the probability that you have a boy taking Spanish. So we're going to look for where boys are taking Spanish. So that's talking about 72 as our desirable outcome on top. So there's 72 desirable outcomes out of, we're selecting just from all the students, right? Out of the total number of students. So, hold on, I'm going to sneeze. Sorry. So we have to add up all of the students. So 58 plus 64 plus 72 plus 56. It's not going to be that it's out of the boy selecting Spanish. It would be like that if the question was phrased differently. If it said, if a boy is selected at random, then that's when you would do just like the boys on the bottom. It would be all students on the bottom. On the top, it's going to be a boy taking Spanish. Oops, whoopsie. Sorry, I had an alarm go off. So what you're going to do, remember you have access to a calculator, so you're going to just plug that into a calculator, and that's going to give you 0.288 right there. So let's now do this one. So we have this figure, and it says assume FG is equal to 26. So like this portion right here is 26. And the two lines graphed above are parallel. If the coordinates for F are A, B, already labeled, then which of the following is equal to absolute value of A minus 7? So we want to find this right here. So already you should see that there's two right triangles, like there's this one right here. Here, let me set the phone down a little bit. So there's like a right angle right here, right angle right here. So you have like this triangle and this triangle. So with this right triangle, that side would be 5 and this side would be 12. And if you've memorized your Pythagorean triples, you would know that this side would have to be 13. You could also do Pythagorean theorem and just say 5 squared plus 12 squared has to equal what this side is squared and solve that. But this is faster, obviously. And then you're going to say, okay, the length of, the length of this side is going to be, well, actually, I already see something, but I'm going to just keep going on my train of thought. Okay, so this side is going out to that A value right there. So the absolute value of A would be the length of this side right here. And what I was saying that I saw is these are going to be similar triangles, and with similar triangles you can do like the sides are proportional, so you can do a ratio with the sides. So like 13 and 13 over 26 or 26 over 13, like those are the matching sides that match up for these similar triangles. They're the sides that should be proportional. So you can ask yourself, like, what do you do to get from one value to another? So like to get from 13 to 26, you have to multiply by 2. So we're going to multiply like each of the sides of this triangle by 2 to get the corresponding side that matches on this triangle, like the side length on that triangle. So if 12 is supposed to correspond with this right here, this side length right here, well, 12 times 2 is going to be 24. So then this side length is going to be 24. So the absolute value of A should be equal to 24. And then you do the same logic for like 5 times 2 gives you what this side length should be, because it's proportional. Like it's basically you just multiply each side by 2 because you know that they're similar triangles. Hopefully I'm explaining that right. Like I know I'm explaining it right, but like so that people can understand it. I mean, I'll try to think of another way to say it. But you're multiplying each side by 2 because you see that to get from 13 to 26, that's what you had to do. So if there's similar triangles, you can do that to each side as well to get the matching side. So 5 times 2 is 10 right there. So now you have the side lengths of this triangle, right? And remember, we're trying to find what the absolute value of A minus 7 is. So technically you didn't even need that side. I was just kind of like showing you that. We already know the absolute value of A is equal to 24. So to find absolute value of A minus 7, it's 24 minus 7, which that's going to be 17, right? Yeah. I don't trust math in my head sometimes at night. So that's going to be 17 as your answer. So it's 2 to 1. Yeah, that's another way to say it. Yeah. So you can like set up a proportion that says it's 26. 26 is to 13 because those are like the matching sides, as the absolute value of A is to 12. And like you could do like cross multiplying that way as well. Like there's different ways to solve it. So let's go to the next one, number 8. So for number 8, the function P models the height P of T in feet of a basketball T seconds after it's thrown. What is the best interpretation of P of 3 is equal to 2.60? So again, with these interpretation problems, it's usually your best bet to pay attention to the units to do it most efficiently. So like it's saying P of T should match up with feet and T should be in seconds. So T matches up with 3 there, right? So you should have some interpretation if 3 is involved, that is talking about 3 seconds, because that's the unit that matches up with t. And then you have 0.60 is matching up with the whole thing, like p of t, when t is 3. So you should be talking about the 0.60 in feet, because they were talking about p of t in feet. So that can help you quickly eliminate a lot of choices. So 0.60 is talking about feet. 3 is talking about feet. 3 should be seconds. Like, I don't even have to read the whole thing. I could just look at units to start eliminating. 3 seconds, 0.60 feet. That matches. 0.6 seconds. No, that doesn't match. So now I can just quickly cross those out and determine should it be A or C. So A says the basketball has a maximum height of 0.60 feet. That's not what that means. What this means is that at 3 seconds after it's thrown, that it's at 0.60 feet or 0.6 feet. It has a height of that, or it's that much off the ground. So it would be C. So let's go to number 9 now. So it says if the graph of 5x plus 10y is equal to 21, or if the graph of that basically is translated 2 units up, then what is the y-coordinate of the y-intercept? So basically we're finding the y-intercept of this new graph. Sorry, can't speak today. So what I'm going to do first is I'm going to isolate y. So I'm going to say, okay, I'm going to subtract 5x from each side. So then I have 10y is equal to 21 minus 5x. Then I'm going to divide by 10 on each side to get y completely by itself. So then I'm going to have 21 over 10, which is just 2.1. Minus 5x divided by 10 is just going to be 0.5x, or minus 0.5x. So if I'm saying that this is my original graph, and I'm going to go 2 units up, to make a graph go 2 units up, you have to just add 2 to the entire function. So I have to just add 2 to this entire thing for it to go 2 up. So my new equation, like once it's been translated, is just going to be like what I get here when I combine those like terms of 2.1 plus 2. So 2.1 plus 2 is 4.1. And then I just copy over this part, minus 0.5x. So if I want to find y-intercept, that just means I plug in 0 for the opposite variable, which is x. So I plug in 0 for x. Negative 0.5 times 0 is 0, so then y would just equal 4.1. So the answer would be 4.1. Yes, correct for the person that said that. Okay, let me just erase that. And now let's go to number 10. So for number 10, we have this data. The data above represents Ava's math test scores for the entire first semester. What is the mean math test score for Ava's first semester math test scores? Okay, so mean, also called average or arithmetic mean, whatever you want to call it, is just the sum of all the data points, in this case, like all the scores, divided by how many scores or how many data points you have. So all you're going to do is just add all of these up in your calculator and then divide it. So like add all of those up and then divide it by how many scores there are. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 test scores. So you would just add that all up and divide by 9. So when you do that, what you're going to get is 85 as your answer. So 85 is the mean. So let's go to number 11 now. So we have the scores up there. The data above represents Ava's math test scores, so same scenario. But now it says if Ava received a 98 instead of a 67, so we're going to cross out this 67 and put a 98. Then which of the following would increase the most as a result of this adjustment? So let's look. I like to start with the easy stuff, like mean. I always call the meanest because you have to do like the most amount of work with it. But like mode, range, and median are pretty easy to just determine like off the bat really quickly. So mode is just the one that occurs the most frequently. So let's look for a number that occurs the most frequently before we crossed out 67. So, the number that occurs most frequently, I don't think there is one unless my eyes are lying to me. Yeah, there is nothing that occurs more than once, so there is no mode at first in the original data set. And when we put that 98 there, there's also not a mode that time. Like, there's no number that shows up more than once in the list, like, or the most number of times in the list. So that's not going to change. Now, range is going to be the highest point minus the lowest point, but you have to be careful because this is not listed in order. So you have to look out of all of these, what's the highest originally? So originally, the highest is 99, and originally the lowest would have been 67. So it would be 99 minus 67 originally, and that would equal 32. Now let's go to the new range. Let's see if there is a new range. So when we put 98 in instead of 67, it's now going to be that the high is 99, and then instead of 67 being the low, the new lowest value of these is going to be 76. So it's going to be minus 76. So then that's going to be 23. So remember, it's asking which of these would increase the most. We originally had 32 as our range, and then it went down. So it's definitely not increasing. So it can't be that one. So it can't be mode, it can't be range. Median would be, okay, I have to put the numbers in order from least to greatest. So like we would start with 67 originally. Like, let's pretend we have the 67. And then we're going to put 76, then 78. Whoops. Then it would be 82. Then it would be 88. Whoops. I don't think I'm going to fit them all there. I should have started more that way. So 82, then 88. Did I do 78? Yeah, I did. 82, then 88, and then 89, 90. Yeah, I'm not going to fit it. 96, and then 99. So that's how it originally is. And then the next, that's the original before you cross out 67 and put that as 98. So then if you were to rewrite this list, it would basically be the same numbers, except now you're going to cross out 67 and you're going to put a 98 in front of 99. So let's talk about the first median, like the first middle number. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 total scores. So the middle value is going to be the fifth one right here, because then there's going to be 4 on the left and 4 on the right. So it would just be 88 as the original median. And then let's talk about the new median. When we put a 98 there, we're still going to have 9 values because we've gotten rid of the 67 now, and we put a 98 before the 99. So it's still going to be the fifth value, but this time the fifth value is going to be 89. So it does increase by 1. Now, the mean is going to be what increases the most, and you could probably figure this out like intuitively already from like without having to do the calculations or anything, but I'm trying to like show you how the calculations support that. So like the mean would be that you're adding up all the values. So let's talk about adding up all the values except for the ones that change. So when we add up all the other values, like we do 88 plus 78 plus 89 plus 82 plus 99 plus 96, and I'm skipping that one, and then plus 76 plus 90, and then plus whichever of these we pick there for the sum of all the test scores or data points, whatever, on top. Oops. And we divide it by the number of data points or number of scores in our list, which in total would be 9. We have to think, okay, how is this increasing? Like, what's increasing about this? Well, this portion, the question mark portion, is going to be 67 at first and then 98 later on. That's the only part that's changing in this when you find the mean. So if you think about it, it's going to be 67 over 9, and then it's changing to 98 over 9 is being added there. So we have to ask ourselves, okay, is that increasing more than 1? So on top, it's going to be, definitely, like you can already see that, but just proving it again. if we see how much it went up, well, it went up by 31 on top, and then it's just going to keep the 9 on the bottom, and then 9 goes into 31 a little bit more than 3 times, so that's obviously bigger than like 1, so it's going to be mean. So that's like the calculations that justify it. So let's go to number 12 now. So we have this system of inequalities, and we want to know which of the following tables represents the solution to all the system of inequalities. So that basically, just like when you were learning about linear equations and you had XY tables, like when you did the whole graphing and stuff with linear equations in pre-algebra and algebra, it's a similar concept. It's just with inequalities. So you're just going to plug in X values into both of these, and then see if you get, if what you get matches what you have in these tables, basically. Like, you're going to check that the table matches the system of inequalities. So first, let's look and let's see, like, strategically what we might want to pick first. So let's see. So this has 0, 2, this has 0, comma, negative 2. I'm looking at 0 because 0 is an easy number, like the easiest number to work with. So 0, 2, 0, negative 2, 0, 2, and 0, 7. So it's probably my best bet to start with plugging in 0, because then I'm going to be able to eliminate at least half the answer choices based off of, well, actually, no, it's an inequality. If it was a linear equation, I could do that. Let's see. Yeah, but they're still all different. So, I mean, let's try. Basically, what you don't want to do is you want to look for like where it's different using easy numbers and start there, if that makes sense. Like, you don't want to start with like one where a bunch of them are the same, and like have very difficult values. Like, I'm not going to start with the -3, -6 ones, because I have stuff with 1 and 0 in it. Like, if that makes sense. So then we're going to just plug in 0 for our x for each of these. So I'm going to say, when I plug in 0 over here, 11/7 times 0 is just 0. So y has to be greater than -8. And then when I plug in 0 for x there, y has to also be less than 5/2 times 0 is 0. Y has to be less than 7. So I need my y in these tables to match where it's going to be greater than -8, but less than 7. So let's see. 2, that is greater than -8 and less than 7, so that works. -2 is greater than -8 and less than 7. 2 is greater than -8 and less than 7. But D does not work because that's not going to be greater than -8 and less than 7. So I can cross out D. So now let's see from the remaining ones. I have, I'm going to plug in 1 now. Well, let me see. How do these change? Yeah, these are the same. I mean, you kind of just have to, like, at this point, I would go with what's easiest. I don't know if, like, the one's going to be the one to work. I might have to end up, like, plugging in -3 after. I'm just going to go with what's easy to hard, because it, like, you can't strategically know from these, like, what would be best by just looking at it. So then let's plug in 1 now for x. So I'm going to plug in 1 for x there, so then I'm going to get y is greater than 11/7 times 1 is just 11/7, and then it's going to be -8. So -8 is the same thing as -8 over 1. I have to, if I'm working with fractions and I'm adding and subtracting, I have to have a common denominator, so I'm going to multiply the bottom and the top by that. You have your calculator, again, on the exam. I'm just showing this for people who, like, want to see the calculations and stuff. So that's going to be y is greater than negative, and that's going to be 45, -45, yeah, over 7. And then now you're going to plug in 1 for x there as well. And then when we do that, it's going to be y is less than 5/2 plus 7 over 1, which we're going to multiply by 2 on top and bottom to get, like, denominators. So it's going to be 5/2 plus 14 over 2, so y is less than 19 over 2. So this is when I would just, like, start plugging into a calculator if you want to get the exact values, or you could say, well, I'm just going to do it in the calculator. You could estimate it too. It's too late for me to be relying on my brain, honestly. So 45 divided by 7, and then make it negative. So this is approximately negative 6.43. And then this, 19 over 2, well, it's just going to be 9.5, is approximately 9.5. So it has to be, y has to be greater than negative 6.4 whatever. And then it has to also be less than 9.5. So it has to be between those. So let's check it out. And let's see, when we plug in x, does the y correspond with that? So 3, that is a value in between these. So that works. And it's the same thing there. 1, okay, is a value in between those. So that didn't really help us out as much. So now we do have to plug in the negative 3 one. So let's plug in now negative 3 for our x. So then we're going to have y is greater than 11/7 times negative 3 minus 8. So then that's going to be y is greater than, let me erase the little part, y is greater than negative 33 over 7. And then remember, this is the same as minus 8 over 1. So to make it have a common denominator, multiply by 7 on top and bottom, minus 56 over 7. So that's going to be y is greater than negative 89 over 7. Is there a reason I plugged in negative 3? Yes, because I'm testing out the answer choices. So like you see how negative 3 is right there for those remaining answer choices? That's why I'm plugging it in to see like which of these fits with what I'm going to get when I plug in negative 3 for x. No problem. So now I've figured out this portion, and now I have to do it with the second one in my system. So now for the second inequality, I'm going to say y is less than 5/2 times negative 3 plus 7. So y has to be less than, that's going to be negative 15 over 2. And then remember, this is plus 7 over 1. We have to have a common denominator of 2 by multiplying by 2 on top and bottom. So then y has to be less than negative 1/2. So it has to be between these values. So I'm not going to trust my brain right now. We're going to do 89 divided by 7 and make it negative. I cleared it by accident. 89 divided by 7. So that's going to be 12.7 yada yada yada. So negative. So approximately negative 12.7 yada yada yada. And then this one's going to be, that's negative 0.5. So it has to be, y has to be a value that's going to be less than negative 0.5, but greater than negative 12.7 yada yada yada. So basically in between those. So let's see what fits that criteria. So negative 6, that is in between negative 0.5 and negative 12.7, so that works. 6 is not, so we can eliminate that, and 6 shows up again there. It doesn't fit that criteria, so it's definitely A.